From my title of the session, you can see that we are going to talk about C# and .NET 7, which is true, but quite in a different way that you usually expect to see in a session like that. I am not giving you just a list of features of bam, 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 what's new in C#. You will get an easier way to read about that on the official documentation, which is very, very well explained. And I want you to give instead a different perspective from getting what is the best tool in town to create a new application. What I am missing from other languages? Why C# take this direction in choosing to offer a new feature instead of what is offering maybe Kotlin or Java or C++ or Python and so on. So it's important also to live and breathe the air of the language's evolution that is coming, because we are living in the same modern workloads. So there is the cloud there is IoT, there is embedded devices. I am an electronic engineer and I live and breathe electronics every way. So I want really give you a different perspective on that. I am Raffaele. I am an electronic engineer that dedicated his entire life in software, so it's a kind of different, but I promise you I have a secret lab where I still have my 3D microscope with soldering guns and so on, so where I dedicate my spare time in electronics and SMDs and creating crazy stuff, IoT devices and so on. And in fact, I am also one of the members of the triage team in the .NET IoT library. And so if you happen to work with the IoT space, or you want just spend a weekend in making something with an Arduino and .NET and so on, come there, because you will have a lot of fun. I also, a long time ago, wrote a book in I mean, you know, the semiconductor physics that's behind the electronics. I mean, it's very good to make the tables stable, because it's very tough. It's a very thick book. And also C# programming. I love that. But I want to speak about other things, not about me. So the main point of my discussion today is, are we using the right tool to write our application? So what's your language of choice? Before me, there were two speakers that were talking about a very important topic, which is DDD, and they asked who is using C# today. And not everybody is with this language, for maybe very good reasons, right? And my point is that we have to choose the right tool. And I want to tell you what are the criteria that I really want to use when I create a new project, which is not necessarily C#, maybe C++, or maybe others. In terms of productivity and evolution and innovation, for example, a very good example is Java, which did not evolve that much. And this doesn't make Java a bad language at all. Java is a very good language. And they consolidated absolutely the language all over these years, and makes a lot of people happy because the language is stable over the years. But on the other side, we have modern workloads that require new tools, new expressivity, new semantics. And so I am going to talk to you about the semantic that is being introduced in the modern evolution of the languages. Some of that in .NET space taken from F#, for example, as they mentioned before. And this is a point that is debated, because a lot of people would like like VB developers, for example, would like that they slow down and don't introduce new features in the language. So a part of the community is not happy with the evolution of the language, okay? And others, of course, yes, but even if they are the minority, we have to understand why. And so another point is manual versus automatic memory management, so the garbage collection stuff. And this is a debated point that starts from a very important discussion that say, oh, I use C++, I don't want to manage automatically the memory because I am smarter, I can decide exactly in a deterministic way when it happens, and I don't want anyone during the runtime to stop me in order to collect and minimize my time in order to manage the memory. But by the way, there are other new approach to this, like Rust, that makes the owning management the main point of managing the memory, so that they don't need a garbage collector, but there is this ownership thing that magically use those patterns that even C++ introduced, like the move constructor that moves the ownership from one guy to another, right? And so you don't have to deal with pointers directly. You just have a smart pointer, which is the class that inherits the ownership of the memory. But what about that? There are other points that memory management involves, that is type safety. And we know that type safety is very delicate things, because if we go back to the 80s, we know that type safety was not such a big problem, because on monolithic application, you have more or less the control of everything. And so you didn't really have to worry too much on that, because the code base was quite short. I mean, it was not huge like our current workloads. That's a totally different perspective. And this involves also the performance, because you say, okay, C# give me the type safety, but there are times where this can cost me a lot, because every time I create a new type and then I move the data in order to fit perfectly the shape of the data with a specific type instead of having a generic object, can give me trouble, right? So there are discussions about that, and we will see again what is happening also in .NET to overcome this problem, and there is not in others. Also, this involves a problem with initialization that was touched from the previous speakers, because initializing an object in the correct state is fundamental, and we have seen already some examples of that. This is not really type safety, but is like application safety, because if you don't have the right state, it doesn't matter if there is garbage or not, or if your application is going to crash or not. I mean, there is already a bug. And so there is something that from the consumer's perspective doesn't change that much. I mean, it's like crashing the application, right? And also, this involves also the problem of communicating and expressing the semantic of the errors. Whereas many C big fan say, okay, we don't want exception, because exception, and we know that, and it's true, takes a lot of time in order to be managed, right? So we don't want exception. We want to return an error instead, because it expresses better that something is not correct, but this opens the debate that we have listened before. So error or data, and I want both at the same time. Functional language are definitely great on this. Also, there is another important problem, which is performant native code generation. This is a super important problem, because if you ask to a C++ programmer, they will say, I have the best code generation, the native code generation, right? I want performant code generation. I don't want IL because at runtime I will spend some time to convert that code in native code. And we will see also this super important problem that has been in the field. So let's talk first about a few things. They are very small things, not that crucial, but give you the idea of what is the importance of having a good semantic in the language. And the first thing is super simple. So even in strings, we still have some improvement. Now, for example, when you express an interpolated string inside, before C#11, you could not go in a new line because you break the rules. This is nothing super, I mean, just a parser from the compiler, right? But we have other things that are very important, like the string literals. String literals are super important because we know that we want to express something that maybe we don't want to load from disk. I have been recently in an Unreal Engine project in C++ where I had to load from disk a file because expressing the same text in the literals was terrible. I mean, literally terrible. You could not express something without replacing things and escaping the literals themselves and so on. Instead, this is a great way to simplify the life to developers. And you see how it's easy. I mean, you just put 3 or 4 or 5 or 6 quotes, and it's up to you to decide. I mean, there is no more discussion on how many do you want to use. If you specify less, you just get the literal. And you have some help from Visual Studio, of course. And the same is valid for the $sign, which is currently used for the braces, right? So you want an interpolated strings, but you have to specify the braces. Okay, you can do it that as well, so you don't have to worry in any way. Another important thing in the strings is the possibility to express in literal the UTF-8, because we know that, I mean, we have a lot of data that must be expressed in UTF-8. After years of discussions about Unicode and the best way to express the data, we know that UTF-8 has won the war, finally. And that's maybe not that good for Asian languages because it becomes very large, but we can say that it's a kind of a standard de facto, right? And you can express this even if you don't have a specific string type that is represented for the literals. You may know the read-only span of T, which is a very convenient way that we will see again in a moment when we talk about the performance, because this type of things matter, okay? Read-only string is a special type that lives in the stack, is not allocated on the heap. And that's the kind of tools that you really need, okay? And also remember that UTF-8 is not just a single byte, of course, otherwise it was ASCII, and this is not ASCII, it's about expressing any kind of Unicode characters. By the way, when you want to interoperate, you also get the null-terminated strings for obvious reasons, because if you want to open a driver under Linux, and of course you have to have a string which is well-formed that is null-terminated. And list patterns. This is a kind of things that was inherited by F# and functional world. So patterns along the way. I am not going to make I mean, a list of all the possible patterns that we have in C# nowadays, but you just get the ones that have been introduced with C#11 that are very, very good. I mean, let's say we have a very simple array, and this array, what does? It's possible to make a pattern in order to have a condition that tells you if the list has a certain representation, which can be, of course, the same is true, and is if quite different because it's shorter. The second one is shorter, is false, and then we have some character that tells I don't care that character. I don't care, so I can skip that one in my check, and I know that there is a pattern inside the array which resembles the original one. And the same is valid with dot dot, which represents an interval of multiple numbers. By the way, the interval can be available just once in the pattern, of course, because otherwise you cannot distinguish how many there will be. And of course, there are also relational operators, which are not new in C#, 11, it comes from previous versions, but that you can combine together with list patterns to obtain more complex patterns. And of course, even this kind of operation, which is greater or equal to, which is very important in order to provide even more expressivity. This kind of expressivity is important because otherwise you have to explain this with the traditional if and be very, verbose in the code, while this is intuitive. We can get the expressivity is a benefit that goes towards the maintenance of the code, and we want that. And of course, you should be careful that an empty array match anything, basically. And you may also want to capture the rest. So the dot dot is captured by the variable rest, which say, okay, now that I verified that the pattern matches, if it does match, if it matches, I can dump what is after the 1 and 2. Okay? And we also, in .NET, get a first class support for new workloads. This is something that is not well known from everybody, but .NET, since it was that .NET Core, now is open source, runs on Linux and on Macintosh, right? And you should know that, but I still read people that is not aware of this. And this is not the only thing. It's not just it runs if you want, if you really want, if you really want. No. It's a kind of first-class support. This is super important. So you already get the apt-get under Ubuntu to get the library, if you want, the SDK, the runtime, or the ASP.NET things. So creating an application with a couple of rows of code is super fast, and you don't get anything wrong. And this is kind of important thing that goes when you work into the containers, right? Because you don't want to spend time and downloading stuff, copying inside the containers, and so on. You just run an apt-get. And this is something that is not only supported, but comes also with other benefits. So the current command line interface in .NET is able to create directly the image for a container, which is standardized, by the way. So you can use Docker or Containerd or whatever else, one of the many, the Podman or whatever you want. And Ubuntu also had a partnership with Microsoft in creating these chiseled containers that are super small. Substantially, they don't have multiple layers where you have the operating system and then .NET and then. But it's kind of a single layer that already is a super stripped, very small, and super light that can run .NET directly. And this is very convenient because the image is super small and even more secure, of course. But even more, we also have rootless containers. So if you don't want administrative privileges inside your container, you can with these other images. And this is another point that makes me happy because I am a big fan of security, of course. There are other workloads that are super important. IoT, I'm very passionate of this because I work a lot with small devices. And there is also another initiative which is driven by the community, which, by the way, is the main contributor of all these libraries on the IoT, which is Nano Framework, which can make running C# on the ESP32 a breeze. Really very, very easy. You have a lot of binding. You can use push button, LEDs, sensors, humidity, temperature, and so on directly in C# on a microcontroller, which is very, very nice. Also, machine learning.net is something that goes in pair with everything we have seen before, because you can take special pre-training models and run with .NET without caring too much about the nature of the network that you built. So you go to OpenAI, for example, you download a model and you are able to integrate this stuff into your code with C# without any problem. Another important thing that I am very passionate with is WebAssembly. And you may know that there are experiments going on. There is Blazor, of course, which is the most popular one, but there are other experiments that makes you work even with an isolator, which is something that you can run even few lines of code inside a WebAssembly that was created on the fly with the purpose to expose a reduced file system, a reduced network to those lines. And you say, well, why should I do that? And the reason is very simple. Because you can isolate the code that was written by someone you don't have control to, like add-ons or the customer code that you want to type on the fly, and you may want to compile with Roslyn in a few lines of code. Roslyn is another point, the compiler, that is super important because gives you the opportunity, and I am a big fan of this because I work a lot with code generation, that give you the opportunity not just to compile your code, because Roslyn exposes the APIs to you and you can parse C#. You can generate directly syntax node on the fly in memory without even having the textual part of C# and then compile directly the syntax node to an assembly on the fly and in memory. And that makes creating code-generated things a breeze. Type safety is one important pillar that I want to talk, because the memory corruption that we see in native especially is very bad. I mean, nowadays, as I told you before, we have applications that must have a very long running life cycle, and so we don't want them to crash just because there is some nasty bug. And this is not something that is given so for granted. For example, we know that Microsoft for the kernel code is going to adopt Rust in order to minimize the amount of buffer overruns that happens inside the kernels, and so to have the mechanism that I mentioned before of constraining the code with the ownership of memory, okay? And this method is used to minimize the crashes, and is used to adopt new strategies in order to avoid these kind of problems. We know that C is not safe, and this is the reason why many are going to Rust, which may be safe, but is not guaranteed to be safe. It depends on how to use that. And this is basically the exact same message we take from C++, which is telling you, okay, if you want to shoot yourself in the foot, you can. You are free to go. Okay, it will compile, and if you want to play with pointers, come on, we are C compatible, so you are free to go. But using pointers, row pointers, is not something that C++ recommends anymore, but since C# C++11, right? So it's something that if you graduated as a C++ developer, already know that you should use smart pointers, okay? And this is something that is completely forbidden if you go to languages like C#. And the difference between the two is huge because you have a different kind of checks. They cannot constrain everything down because the checks are done during compile time. And that's the main difference of the language. So everything that you get just when you compile is very difficult to constrain. And you can do it with Rust just because they adopted a kind of strategy that is a sort of source verification, and they qualify every variable that is passed in memory with a semantic that forbids you to lose control over the variable and the boundaries, which can be tough for the first time that you start to use it because it's a steep learning curve, in fact. It's not easy to do it. But in languages like Java or C#, instead you have a kind of virtual machine, the CLR, the JVM, that controls what your program is going to do at runtime and stops you from corrupting the memory. Maybe they give you an exception, but that you can catch that and go on. And also the adoption of garbage collectors that I mentioned before. And I want to underline that I'm still surprised to see C++ programmers that tells I don't want the garbage collector is bad, while you have an excellent example of Unreal Engine that makes the use of garbage collector a first-class support, because otherwise the games could not last an entire day from the typical gamer that spends his entire life in front of the game. There's no way that memory can survive that. I mean, that's no way. You have to compact your memory. You have to have something that helps you in managing that. Otherwise, the fragmentation, even if you have huge banks of RAM, you will finish contiguous amount of memory, and you will get before or later an out of memory exception. There are a few strategies to overcome this problem. The first is minimizing memory copies. So if you are a C# developer, you should try to not exaggerate in your reference type, please, because they go to the garbage collector, and the garbage collector is in the heap. And the same is true also for C++ programmers that continuously make a new. And you know what you get is something that before or later will slow down, because the new in C++ depends on the heap that you are using, but can be quite slow. And you know what? Allocating a new object in C# can be very fast, because it's just moving a pointer, making an addition, and nothing more. So the problem is not that trivial, okay? But if you give a lot of allocation that must be removed quickly, the garbage collector is very fast, because it stays in the first generation of the garbage collector. If they survive and go in other generation, it can become slow. And so it's up to you as a developer to understand how memory works in .NET and use that. Instead of this, you can just use value types. And we have a lot of tools to make that work. And a well-known object state in initialization is something that we heard before. It's something that is not really type safety, but I mean, I want something that makes sense in my application, in which the semantics does mean something. And also another common tool, not used by every language, but from many, is the use of templates or generics, which, by the way, are very, very different, because a template in C++ has nothing to do, is expanded at compile time, because C++ is a compile time language, while the generics are evaluated at runtime. And this makes a huge difference in what you can do, okay? And in order to make a better memory management without making the life complex to developers, because this is the true challenge, right? You can do astonishing things, but if you have complexity, it isn't worth it, right? And this is like span of T and memory T that are two important tools that if you still don't know, please look at it, because span of T is able to maintain an object and guaranteed to be inside the stack, okay, is allocated on the stack. This means that you don't have nothing to do with the garbage collector, and you can make it faster, and you can just forget of the problem, okay? Also, you have a new important feature that the master of the guru of the garbage collector, which is an amazing person, Mauni, is the woman, the Wonder Woman of the garbage collector, which is the main architect and designed all this nice thing, that migrated all the code for .NET 7 to a new kind of management that instead of segments we have regions. And this demonstrated on the tests that is more efficient towards now the modern workloads. This is another important feature that we get. And also, we have that is upcoming in .NET 8 in this November, a new strategy for the stack unlock. And you may ask me why I am talking to you about this stuff. You don't have substantially to do anything. And this comes back to the initial to the start of my presentation. You have to question yourself if you are using the right tool, because when you see something that is progressing, giving you innovation and improving version after version, it makes a huge difference on your workloads, even if you don't touch the code. I have trouble in communicating to certain customers why they should upgrade their runtime to the newer versions. And they, why are you asking me? Yeah, it's okay, the application is working, I don't want to touch it anymore. And that's bad. I mean, software dies, guys. They are like humans. You spend time in waiting and they start dying. And you have to completely feed like a baby. It's important to continuously maintain, evolve, and provide new features, because otherwise they don't respect the new requirements that the modern workloads require. I don't know why it was reset in the presentation, but that's interesting. Okay, one of these semantic that is important is the introduction of the required keyword. This is something that guarantees that you can initialize an object correctly. What does it mean? That normally you get, for example, this simple class and you say, okay, have a company with a string name, but you don't want necessarily to provide a constructor taking all the parameters, because you may have good reasons not to do that. But you still want to use this semantics, which is very good when you have a long list of parameters, because the constructor that is longer, like let's say the 4 or 5 parameters, is crappy, definitely. Okay, you don't want that. And there is the problem that you can still create an object without a name. So the new improved things is that while you are still initializing the object, so this kind of state of the object has been last a little bit longer of what normally is, beyond the constructor itself, introduce the required keyword that say, okay, as soon as I finish the initialization, I pretend that you initialize the name, otherwise the object is corrupt. This is something that I have to warn you with the compiler error. Yeah, I mean compiler error. That's super important. And this is the set required members, is a way to avoid the initialization if you have to parse, as we have seen before, the members. And also, we have seen another nice feature, which is the static abstracted interfaces, which is kind of earthquake for many people, because you know what? You don't want static abstract, static things in interfaces. But math required this, because since the very beginning, the operators that are inside mathematical operation, the classes, you can only express them as static members. And for this reason, we have introduced these things, which is basically something that helps you in creating mathematical libraries. So now you can declare in interface static members that are operators or others, and they can be virtual, so that you can overload them, implement them. And this results in a very important thing that I want to show here. If you go to see int32, now inherits a very long list of interfaces that has exactly this behavior. So there was, you see, I number, I additional operation, I additive identity, and many, many others. They can be as long as, boom, you see, in green, the list is super long. And this makes creating mathematical libraries very easy, because you get an incredible classification of everything that is numeric involved. And you can also create your own implementing those interfaces. So it's an opportunity that it's astonishing. On the performant code generation, I want to convince you that .NET is substantially doing the same good job of C++. Let's see if I can do it in a few minutes, in the minutes that still I have here. And the tiered compilation is something that happened before in .NET. And we only had the ready to run, which is a way to transform directly with your compiler the code directly to native. But since we have generics that cannot be expanded at compile time, a few bits in IL are still there in order to resolve at runtime certain things. And the tiered 0 is the one that is fast to generate, but is not very performant because it's fast to generate. So the just-in-time compiler, when it takes the IL and converts to native, it's trying to do the best he can in a small time, because you want to see your application popping up as fast as possible, right? If you run inside an AWS Lambda, for example, you don't want to waste your time in compiling, because, I mean, it's something that serverless required to be super fast, okay? The tier 1 is something that happens when you have you observe, at least the runtime observe, that there is at least 30 or more times of the execution, and you say, oh, this is a hot call. It deserves to be recompiled, and it's completely recompiled by the runtime. This is good, but not optimal, because the loops, for example, is something that happens very often, but this is not a call. And this means that they will not recompile so often. So we have now two strategies that you almost have not to understand fully, because they happen under the hood, which is on-stack replacement. Is something that when your application is running, the application is able, your runtime is able to recompile the code on the fly, even if there is not a new call. So the famous loop that is running a million times can be recompiled while it's running, and at a certain time the stack is swapped so that it can continue in a faster way. As this is turned on by default, and this is why when you look at the benchmark that Microsoft presents to the public and say, oh wow, again, new benchmark going even faster. How is that possible? These are kind of things that makes their code and your code faster. Another is PGO, and who is proficient with C++ know PGO very well, because it's an instrumentation that you get, but you have to compile the code in a specific way in order to obtain. And then this dynamic PGO is something that is sampling your application continuously. And as soon as you have enough data, it gets profiled and then recompiled through the on-stack replacement that I mentioned before. And turning it on is just putting through with this in the CS project. It's extremely simple. The good thing, and this is my last point, is that now you can have totally native code. So you don't get IL anymore. You can do it. And I ask you, are you sure to want that? Because you get really no GT compiler at runtime. You get pure C++ compiled code optimized since the very beginning when you compiled the code. So everything is optimized at the maximum extent like C++. Okay? What you obtain is an application that only depends on libc, like C++, nothing else. But there is no free lunch, like someone told before. So even if we cut everything to obtain a smaller code as small as possible, what you obtain is cannot use reflection, for example. You cannot use expression trees. You cannot dynamically compile things. For example, the entity framework guys are working in order to pre-optimize queries with link in order to get the execution also work on this specific code and scenario. So you have to be very careful. But if you want a real super fast running code since the very beginning without jitting, that's a solution. The outcome of this is that explain you why Microsoft has worked on the C# code generator all over these past versions of .NET. And that means that you basically get a kind of pair programming help from the compiler, which while you are typing code, he types the other part of the partial class and give you code generation that will happen during the compilation. But while you are typing, you get someone that is creating code for you on the basis of the attribute that you put on the code. And if you want to see that, you have different possibilities. The first is library import that generates the P invokes for you. The second is the generated code in place of the regular expression. Okay? Because otherwise, with the native IoT, you don't get regular expression because it's automatically generated at runtime. You get a serialization and deserialization with the same code generated. So what you obtain is something is custom converters on the fly when you are typing. And also JavaScript interoperability for the WebAssembly, for example. And finally, if you want to sneak at my code, I created a very simple generator for the iNotify property changed here. Summing up, we have .NET and C# that are growing very fast, and I hope to have transmitted you the reasons why all of this is important. C# is on the overall top most loved languages, and there is a reason for that, because the evolution is important. And it is open source, and they are running fast. This is good for the ecosystem, because there is place for growing even more. And if you have other questions, please reach me out of the room, because we are getting late from the previous questions of the previous. My clock is 45, and I hope you enjoyed my super fast.
Fast and effective.
Yeah.
Quick and sweet.
Thank you very much.
The way I like to say it. Everyone, any quick question? I've got one quick question.
Yes, please.
Which of the new features that's in your I mean, top one.
Code generation is something that I love most, like library import, which generates the platform invoke declaration for your interoperability. Something I am very involved in code generation for many customers which want to customize the code for their customers in order to specialize the code on the fly. And so with a couple of flags, you completely change the backend, generate the controllers, the access to the database and customization, all the classes. This is something that other languages can't do in any way.
Well, thank you very much for sharing from your experience. Welcome at CodeCamp and see you next time.
Okay.